All right, so take a look at this polynomial for problem number 1 here. If I told you factor that, what would you be thinking? I mean, maybe your first thought might be, okay, it's an x cubed. The only thing you really learned is grouping, so you might take a look and see, well, could I use factoring by grouping on that? But factoring by grouping would not work. Over here, you could pull out the x squared, but you'd have 2x plus 9 left. That wouldn't match the 7x minus 6 here. So factoring by grouping would not work. There's no GCF for the whole polynomial, so there's really no factoring techniques that you know that are going to work on this. Now, I am giving you one little head start, though. I'm giving you one of the factors. So we know when I factor this, it's going to start out with x plus 2, and then we just need to figure out what else. X plus 2 times what is going to give me this cubic polynomial? All right, well, what if I told you 4 times something equaled 192? How would you find the something? Of course, you would divide, right? If we want to know something time, if we've got x plus 2 times something, what are we multiplying by to get this answer? The way we figure out what do we multiply by is division. Division is the opposite of multiplication. So we're going to do this division problem here. So that's going to be our tool for factoring today, is to use division. So isn't it nice that we learned a quicker way to divide, right? We don't have to do long division every time. We're going to be dividing by these things that are linear all the time today, these things that just have x to the first, and so we can use synthetic division. It'll be much, much quicker. Just make sure you remember, make sure you're careful when you're doing this here, which number goes in the box. We've got x plus 2, so do we need positive 2 or negative 2 in there? We need negative 2. So that whole idea that x plus 2 equals 0 means x equals negative 2 is the solution. Okay? And then always double check, is this in standard form? Is it written in order? Are there any missing terms? But that all looks good, so we can copy those down. And then hopefully remember this process. The first number just gets carried down, and then you multiply those and add, and then multiply and add, multiply and add. Now there's going to be a nice check today for whether or not you've done this division correctly. We knew that x plus 2 had to be a factor. Remember that factor theorem that said a bunch of things are equivalent? One thing we knew was that if something is a factor, then when you divide by it, you have to get a remainder of 0. So if you get that 0 remainder, then you probably did your division correctly. Okay, so we got 2x squared plus 5x minus 3. Remember, it goes remainder and then constant x to the first, x squared. Okay, so we know that x plus 2 times this quadratic equals this cubic polynomial. Now we do want the complete factorization though, so we're going to take a look at this and we're going to factor it further. Let's just go ahead and do that over here. So we know we need 2x and x, and then it looks like we're going to want plus 6x and minus 1x. And so then there's our answer for this problem here. There is the complete factorization. Now that was almost kind of cheating though. I gave you part of the answer. I already gave you 1/3 of the answer, one of those factors. It's not going to happen a lot of the time. Normally we're just going to give you the problem and you got to figure out the whole thing yourself. So what about this one here? It's the x to the 5th polynomial. That's a pretty high degree polynomial. It's got 5 terms here. Grouping's definitely not going to work. So what are we going to do? Now notice this one says find the zeros and factor. It's not really that much more work though, because if we know the zeros, we know the factors. If we know the factors, we know the zeros. Like back on number 1, if I wanted the zeros, they'd just be -2, 1/2, and -3, right? The zeros and factors go hand in hand. So I'll give you a hint. The finding the zeros is what we want to do first. We'll find the zeros first, and that'll allow us to factor. But how are we going to find zeros for this? Is there any tool, anything at all that we could possibly use that would help us find some zeros? Oh, we could use our calculator, right? Our calculator could find some zeros for us. Thank goodness that we live in the 21st century. Before they had graphing calculators, they actually had to kind of guess and check, just guess and check possible zeros and see which ones work. And then once you found a couple, um, then there's a systematic process. But they just had to start guessing and checking. There's something called the rational root theorem that tells you what possibilities to check. You look at like the factors of the constant, the factors of the leading coefficient. So I think here they would have had to check like plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and just try them until they found something that worked. But we've got graphing calculators. Thank goodness for that. Okay, so here's the graph, and so of course zeros, roots, x-intercepts. We want those points on the x-axis. Okay, so if we're looking for this one, we could use calc 0, but it looks like it's probably -2, right? Now we're not sure right now. It could be -1.9. We could use calc 0 to be sure, or if we think it might be -2, there's a quicker way to check. Let's just use trace. If I hit the trace button, then I can type -2, and it does tell me y is 0. So I know for sure that -2 is a 0. Okay, so let's see what we get from our calculator here. We've got -2, and then over here, that looks like it's 1, right? We're not 100% sure right now. To be 100% sure, just use trace, and then type 1, hit enter, and yeah, the y is 0 there. So looks like 1. Okay. Now x to the fifth, normally we'd think that there could be, up to 5 zeros. So this doesn't seem like a lot of zeros. Like x squared, usually, the maximum possible is 2 zeros. X cubed, x to the third, this one has 3 zeros. Remember that relationship between the degree, the highest exponent, and the number of zeros. So maybe you might be thinking, I wonder, maybe there's some more hidden in here. This looks right now like maybe it could be a double root. It could just touch the x-axis, but you're not sure. So you might want to investigate further, maybe do a zoom box and just draw a little box, a little tiny window right around this spot right here, and try to take a look and see, does this actually just touch, or does it actually cross through and have multiple solutions? That's that's looking like it's probably just touching here. If you really want to be sure, you can do zoom box again. Let's really narrow in on this here and see, is it just touching? Looks to me like it is. So it looks to me like this 1 right here is a double root. Okay. All right, so those are the zeros that we've got from our calculator. Now we also want to factor this thing though. So again, we've got to divide. So x equals -2 tells us again that x plus 2 is a factor. So we're going to want to divide by x plus 2. X equals 1 means x minus 1 is a factor. We want to divide by x minus 1. But actually we're doing synthetic division, and so we don't really have to think about that too much. I mean, you can say, okay, I'm dividing by x plus 2. That means the -2 goes in the box. But it's actually whatever these zeros, whatever these roots are, that is the number that goes here. So you don't really have to think through that too hard. Okay? Now there is one thing to be careful about right here. Do you see what it is? Do you see what some people might miss? Take a look at this polynomial. It's missing the x to the fourth term, right? We need a 0 in there. You skipped that x to the fourth there. It went x to the fifth and then x to the third. So we'll put that 0 in there. So then we've got 1, 0, 1, 2, -12, 8. And we can maybe go a little bit faster because again, there'll be this nice quick check of whether we did it right. So I'll copy it down, and then I'll multiply, add, multiply, add, multiply, and add, multiply, and add, multiply, and add. And I got my 0 remainder. So I know I did it correctly. Again, because these have to be zeros, because x plus 2 would have to be a factor, I know 0 has to be the remainder. Okay? And then I also want to divide this by x minus 1, by this x equals 1 root. Okay, you could write out the polynomial and then do a separate division, but what you can actually do is just kind of keep dividing here. If I wrote out this polynomial and then wrote out its coefficients for synthetic division, I'd be back where I was right here. So let's just keep dividing. Let's divide the answer that we got by x minus 1. By this x equals 1, 0 here. All right, so we'll do synthetic division again. Copy it down, multiply, add, multiply, add, multiply, add, multiply, and add. There we go. We got this 0 remainder. Okay. All right. So now we've got a couple choices here. So one choice, I could write out what I've got here. Okay. So it's constant x to the first, x squared, x cubed. So I've got x cubed minus x squared plus 4x minus 4. Okay. And so I'm still at x cubed right there. X cubed, we don't always know what to do with. Back here, x cubed, I didn't know what to do with that one. And so I had to divide. So if we just get down to cubic, usually our goal is to get down to a quadratic because we know what to do with quadratics. What about this cubic though? Well, this one grouping would work, right? Can you see that if you did the grouping, take out the x squared and then take out the 4. These x minus 1s here are the same, and so grouping would work. I could factor out this x minus 1. Okay, so that's one option. Another option is because it was a double root, that means that x minus 1 squared has to be a factor. That means x minus 1 has to divide into this twice. So I could divide by x minus 1 again. If it's a double root, you can do this division twice. And this is actually going to confirm whether or not it was a double root. I didn't actually necessarily have to do all that zoom box because right now I'm going to be able to tell for sure if it was a double root. So I'll copy down that 1, multiply, add, multiply, add, multiply, and add. And so now I am at a quadratic, and so now I am all done for sure. This is normally our goal to be able to get it down to this quadratic here, right? And so I can see that there aren't any more zeros. If I tried to solve this here, I'd have x squared plus 4 equals 0, x squared equals negative 4, and then trying to square root that, square root of a negative, of course, is imaginary, right? So I'd have plus or minus, that would be 2i. Normally in pre-cal, we'd spend a little bit more time actually trying to find some of these complex number or imaginary number solutions. But AP Calculus is all real numbers. We're short on time for distance learning. So we're not going to worry about imaginary number solutions. We're just going to do everything all real numbers. All right. So my only zeros are -2 and 1. And you don't have to say that it's a double root, just the only zeros we could find are -2 and 1. Now for factoring though, we're going to have to pay attention to that. So factoring x equals -2 goes with x plus 2, and then x equals 1 goes with x minus 1. And then we've got this x squared plus 4 here. Now this isn't quite right though. See if you can spot what's wrong. One way to do a nice quick check is always check this leading term right here, because sometimes there's some things you might have forgotten or something you have to tweak a little bit. That x to the 5th, so if I multiply this out, I'm supposed to get x to the 5th, but right now I've just got x times x times x squared. I've only got x to the 4th right now. So I'm missing something here. Well, it was because of this double root right here. Because x equals 1 was a double root, I need x minus 1 squared in my factorization. And now x times x squared times x squared would give me the x to the 5th. Okay, so that's my factorization for this one. All right, so let's try another one here. Let's try number 3. So we want the exact values of all the zeros and factor it. Okay, so we're going to start in our calculator. That's where we're always going to start on these. These will be calculator problems. We live in the 21st century, so we can use our calculator. We don't need to guess and check. Don't need that rational root theorem. Okay. All right, so let's see. So if I take a look at this, it doesn't look like any of those are nice integer numbers, right? None of those x-intercepts look like they're on tick mark. So I do have to actually use calc 0 now. Okay, so we'll try calc 0. And so I'll do from -7 to -2. Again, you could just use the arrows if you want. I usually just type in numbers and then hit enter for the guess. So it's about -4.562. X is about -4.562. Okay. Now here's the problem though. Notice I had to use a squiggly equals. I had to say approximately equals. I wanted the exact values though. This isn't the exact value. And well, what if I write down all those decimals? What if I write all this down? Well, then we'll be at the exact value. It won't. I can quit out. I can show you if I type X, that decimal actually goes on further than it was showing me before. So what if I just write down all those decimals? Well, that's still not the exact value. This decimal keeps going. This is just as much as the calculator is going to show you there. Okay, so when you get kind of like an ugly decimal like that, we're going to have a little bit more work to do. We want the exact value. This exact value thing here means no ugly decimals. No decimals that go on forever without repeating. Okay, so this wasn't exactly what I wanted. I'm going to have to do some more work for that. Okay, let's keep going. How about for that one, I can do maybe from -1 to 1. Okay, another ugly decimal, not looking too good so far. So -0.438. All right, one more. Let's check this one. So how about calc 0, I'll say from 1 to 5. Hit enter. Okay, how about that? That one is a decimal, but is that one okay? That's an exact value, right? 2.5. That's not approximately. I can say x equals 2.5. That one, it does exactly equal that value. That's a specific value. I could call it 5 halves, right? If I wanted to. There's no rounding going on that one. Okay, so I like this one. This one's an exact value, but those decimal approximations aren't good. Okay, so I need to go through this division work so that I can figure out what the exact values of these decimals are. So you can pick either the decimal or the fraction. We're going to do synthetic division with this more challenging number here. Again, pick the decimal or the fraction. I'll do the decimal. And so really what we're doing is dividing by x minus 2.5, or dividing by 5x minus 2, or sorry, 2x minus 5. But again, just whatever the 0 is what you put in the box here. Let's see, terms are in order, no missing terms, so that's good. Okay, do this synthetic division, copy it down, multiply, add, multiply, and add. And it's kind of like 4/4 is a dollar, just with the decimal place. And then I know I did it right because I've got a remainder of 0. Okay, and so now that I'm down to this constant x to the second, I'm down to a quadratic. That's what I wanted, because any quadratic we can solve. That's kind of our goal, is to get 1, 2, 3 zeros, however many we need from our calculators, so that then when we divide down, we're down to a quadratic, because we can always handle quadratics. Okay, let's try to solve this to find the exact values of those decimals. So 2x squared plus 10x plus 4 equals 0. And then let's just divide everywhere by 2. It's got to GCF there, x squared plus 5x plus 2 is 0. Well, wait a minute, that doesn't factor. That one's not factorable. Well, if a quadratic isn't factorable, we don't just give up, right? Hopefully you know how to solve any quadratic in the world. Because this is odd, completing the square wouldn't work too well, so this is quadratic formula. We do expect you to know the quadratic formula. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. If you forgot the quadratic formula, listen to it on YouTube. You'll get it stuck in your head pretty quickly. And so we've got -5 plus or minus the square root of 17 over 2. And then we also had 2.5 from before. Don't forget the one that you got from your calculator, the easy one. Okay, so those are our zeros. Here's our zeros here. All right, so this is the exact value of these decimals right here. All right, so if you wanted to check your quadratic formula work, you could calculate that. You could say -5 plus the square root of 17 over 2. And there we go. That matches one of those decimals that I found earlier. But now it's an exact value. All right. So there's the zeros for factoring. You could say x minus 2.5. And then this that we had right here, 2x squared plus 10x plus 4. That's one possibility. Or you could say, well, if we're trying to do a complete factorization, if it had a GCF, we probably should pull that GCF out. So if you factor out the 2 out front, you could have this. Right? I'd accept either one of these. Or another possibility is instead of saying x minus 2.5, if you think about it like 5 halves, you might be thinking that, well, you'd have 2x minus 5 would be another way to get that 5 halves 0. Okay, but if you do this one here, you've put the 2 in with this one, and so here you would just want the x squared plus 5x plus 2. Okay, so any one of these are acceptable. Again, just always check and make sure that this leading term is working out. So any way that we do this, we need 2x cubed when we multiply those first terms together. All right, so any one of these is perfectly acceptable for a factorization. Your choice, right? So why don't you go ahead and try a couple of these problems now. So one of them factoring, one of them finding the exact values of all the zeros. And again, it doesn't really matter which one we're asking you. Factoring, finding the zeros, they go hand in hand. You know the factors, you know the zeros. You know the zeros, you know the factors. All right, go ahead and give those two problems a try. Right, so you can check your answers here. So on number 4, you actually didn't have to do any synthetic division. Your calculator, actually all those zeros were exact values. 0.6 repeating is just 2/3. And so if all those zeros are nice numbers, then you can just go ahead and write out your factors and you're good to go. I mean, of course, you could have synthetically divided by 4 or divide by 2. You could have done some synthetic division. You should have gotten down to the same stuff. But when they're all nice zeros, you can just write your factors. Again, just be careful about this leading term here. If you just said x minus 2/3 for this last factor here, you need a -3 in front to match that leading term, that leading coefficient. You could have also written something different for the 2/3, and then your leading term would have matched up. And then on number 5, got a couple nice zeros from your calculator. Synthetically divide by those, and then take that x squared minus 7, and that's a pretty easy one to solve there. All right, so again, from our calculator, those were the only exact values. These other two, those would have been kind of some ugly decimals. So for exact values, we didn't want those ugly decimals that kept going forever with no pattern. No ugly decimals when we say exact values.